Recording now.
All right. Good morning. Good day to all. We are here on day 2 of IEEE Blockchain Get 2022. My name is Gora Data. I'm the General Chair for the forum, and it's my pleasure to welcome all of you. We had a very exciting day yesterday. The excitement for us internally was there was no hiccup. As organizers, you always worry about that. The day not only went off very well, we had some very excellent presentations right from the keynote to the various tracks and sessions. And it's a 12-hour coverage. Yes, we had breaks in between. We start at 7 a.m. Pacific and we run through till actually 7:30 p.m. Pacific. So it's a 12.5 hour of marathon sessions, exciting activities throughout. And yes, we are recording these and these will be available later on, but you'll have to register as a value attendee to access the recording, and I'll drop the link for that subsequently on the chat. And we will also send it out as an email to all attendees. We have some interesting and exciting statistics to share with you all, some of which I repeated, which I mentioned yesterday, but I'll go ahead and repeat and give you a head count. We now have 1629 registered attendee, 1629. It wasn't a few weeks ago where we were said we'll be happy to have about 100, 200 registered attendees. So we are really glad to see the IEEE Blockchain Initiative now has over 1,200, 1,300, maybe even 1,500 new participants who have come into the fold, and we now have a larger team who will be helping us move forward. As a part of our lineup for today, all of you have the Hua app, and whether it's on your phone or in your desktop, take a look at all the various tracks. We have some fascinating keynotes today, definitely, but then the various tracks, many of them are obviously in parallel. So pick your choice. You have the option of plentiful here. And what I would like to do at this stage, maybe just quickly invite the chair of the IEEE Blockchain Initiative, co-chair Ramesh Ramadas, to say a couple of words, and then invite other members as well. Thank you.
Well, thank you. Thank you, Gora. So I think I'll just go ahead and introduce the speaker in the interest of time. We have Rick Kuhn. He's a computer scientist at NIST, specifically Computer Security Division, and he's a fellow of the IEEE, and his current research focuses on autonomous systems and combinatorial methods for AI assurance. He has authored 3 books and more than 200 conference or journal papers on cybersecurity, empirical studies of software failure, and software verification and testing. Rick, you there? I will let you share.
Yes, I'm here.
I'll stop. Please take it from here.
Okay, so I should go ahead right now?
Yeah, you could go ahead. Yeah.
Okay, sharing screen.
I see the screen.
Slideshow.
Perfect. I see it. Yeah.
Okay, very good. Okay, well, thank you, Ramesh, and I wanted to thank Gora Data and Latif Ladid and the other organizers for giving me the opportunity to talk. I was especially interested when I saw this slogan down here in the logo, blockchain and beyond, because that's really what this talk is about today, is taking some of the ideas, the foundation of blockchain, and building on that for other applications. And so that's what this talk is about. As to why you would want to listen to this. Well, we all who are attending this workshop know that blockchain has some really valuable properties. But one of the issues about blockchain is that it does conflict with the privacy requirements of many regulations. So in particular, there is a privacy regulation from the GDPR, and also some US states now are moving to a rule that says a user must be able to delete their private data. And so that is, of course, not possible in blockchain because by design and with good reason, the blockchain data is considered immutable. You can't change the data without, of course, disrupting the entire blockchain, which makes it intractable. So the idea that we have is looking at some of the features of blockchain, but allow for this privacy feature to be added so that we can meet some of the requirements of regulations. And so what we've come up with is there's a structure which we call a data block matrix. And the idea is to allow the distributed trust, the integrity protection that you have in blockchain based on hashing, but also allow for controlled edits for privacy to meet the privacy regulations, or for corrections in data. This could be a useful thing in many applications. We also very happy to announce at this workshop for the first time, we have a drop-in compatible component for Hyperledger Fabric that implements this, and this is going to be released in just a few weeks, possibly sooner. So what's the idea here? Well, blockchain works pretty nicely for cryptocurrency. There are some performance issues, but those are being worked out. But the nice properties of blockchain have made it attractable for distributed systems in general. However, if you look at some of the research that's being done, you'll see that a lot of it is kind of directed at trying to get around the built-in properties of blockchain, ways to deal with privacy issues by spending down tokens and that sort of thing. So what we're looking at is again, trying to do something that is building on the foundation and the basic ideas of blockchain, but allow for a different capabilities. And what we'd like to do is basically take this boundary and move this boundary out. So this is our blockchain and beyond, trying to move beyond the current limitations of some of the blockchain applications. Quick review, probably not necessary for this audience, but this is how the traditional blockchain is, of course, set up with linked together chain of hashing. But the key points here, again, just to repeat, that we can record transactions between two parties in a verifiable and permanent way. So what we're going to do is we're going to allow the verifiable part for the distributed trust, but remove this constraint of permanence. So why is that permanence a problem for applications? Well, as noted earlier, it is difficult to support privacy regulations or impossible, such as these. So the GDPR requirement, I think most people have heard of this at some point, is quite specific. There's been a lot of discussion in legal journals and policy journals about this issue, where a user must be allowed to have their personal data deleted at their request. They define personal data in this way: any information concerning an identified or identifiable natural person. Of course, that's what blockchains are typically designed for, the data, the financial data and so on that may be personal. And this is an important point: personal data that have undergone pseudo-anonymization, some sort of obscuring of the data, is still, if it can still be attributed to a natural person, then it is considered personal data, and that must be deleted at the user's request. That was the GDPR, but there are US states adopting this as well, California, Virginia, Colorado, and others, I think. And I believe that other countries are moving in this direction as well. So this is becoming an important need to support in distributed ledger. So quick look at some of the properties. Blockchain works for, well, in most cases for cryptocurrency. But if we want to do supply chain, logistics, business applications, it's a little bit different. Typical properties cited with respect to cryptocurrency applications, partial anonymity, not fully anonymous, of course, and that's well known. But for many business applications, there is a need for a strong ID because if you're dealing with contracts or regulation, then you need identification. Public access and transparency. What I'll be presenting today was primarily designed for permissioned blockchain, permissioned distributed ledger, I should say, applications, not intended for cryptocurrency. So not the exciting cryptocurrency, but we think it has a lot of economic value. Typically, cryptocurrency, you have relatively small transaction size as opposed to videos, images, large documents, and so on. And this is the key point here, immutable records, point number 4. We need to allow for changes and deletions, and these are often required by law. Privacy regulations are one. There may be other legal reasons to do this. So if we can accommodate these rules, then we can expand the utility of distributed ledger applications. Proof of work, that's a well-known issue in cryptocurrency. If we're doing something that's a little more flexible and we have a broader range of applications. And block ordering, decentralization, these are somewhat similar between the two. But this is the key difference, again, being able to do deletions. So there have been attempts at solving this issue of the conflict between privacy needs and conventional blockchain approaches. One important point, pseudo-anonymized data is still considered personal, even if it's just a simple IP address. And this is an EU ruling at some point. A dynamic IP address that could be tied back to an individual is still considered personal. So this gets very complicated in addressing this requirement. Financial transactions, obviously this is in many or most cases personal data. Another idea that's often proposed is to encrypt data and then keep the key and destroy the key to make the data inaccessible. The problem with that, of course, is that data needs to be secure for many, many decades. I'm from NIST. I am familiar with the history of cryptography and the data encryption standard and so on. The typical history of cryptography shows that in a few decades, maybe sooner, cryptography will eventually be compromised, or many current crypto algorithms will be compromised. And this is, of course, the most well-known example. Quantum computing would put conventional public key systems at risk. So there's an effort to get around that. But the key point here, of course, is that this is not really a useful way in most cases to deal with this privacy issue. But a lot of blockchain applications don't really necessarily need all the properties of blockchain. They value the distributed trust, they value the integrity protection, but they don't need all of the features. So what we're trying to do is do something a little bit different, which we'll show in just a minute here. And there is code, example code of the algorithm available online. And we have a full component for Hyperledger that's going to be released, as I mentioned earlier, very soon. This is an important point. We are not trying to replace blockchain. What we're trying to do is provide an alternative tool that gives you many of the properties, many of the capabilities of blockchain, but will be more suitable for some applications. And that's the nature of all software engineering, or all engineering in general. Some tools, some data structures, some algorithms are useful for some applications, but not as useful for others. In some cases, you'll want to use blockchain. In other cases, this may be a useful approach, an alternative. So the constraints of this data structure, first is we want hash protection, to guarantee that blocks that are not to be deleted or have not been disrupted. We want to allow auditability. That's sort of, we might say, one of the most valuable aspects of the current distributed ledger applications outside of cryptocurrency. Auditability within logistics is a complicated process. Not as flashy as cryptocurrency, but it can be very valuable. And we wanted to provide distributed consensus to allow that auditability and a shared view. And I noted this is for permissioned or private distributed ledger systems. Supply chain logistics, food logistics is one, but many other logistics applications and supply chain applications as well. So getting into the data structure and how this works, what we've done is really simply have two different hash values. So this is what the matrix would look like as in a tiny example. The blocks, data blocks here, for each row of data blocks, there is a hash of that row. And for each column, there is a hash of that column. So this block right here is protected, hashed by this hash value and this hash value. Simple enough. And every block within the matrix has two hashes in this way. So the way this works, let's say we wanted to delete block 12 right here. So that, of course, if we delete this, that disrupts this hash value over here. And it disrupts the hash value for column 2. However, it doesn't affect this column or this column, and it doesn't affect the other rows. So changing this, we can change this, we ensure that this is changed without affecting any of the other blocks, because they're, the fact that they have not been changed is guaranteed by these two other hash values. The algorithm itself is very simple, just a few lines of code. And as we apply that, we generate blocks in this fashion, 1, 2. So basically bouncing back and forth across this diagonal. There's a reason for that. It has some useful properties, useful for performance, we think. Very simple, and there are many other variations, of course. Some of the basic properties of this, again, we have half above the diagonal and half below. This keeps it as a square, basically a square matrix. The length of the hash sequence, of course, for n blocks would be proportional to square root of n. The number of blocks, if we have k rows and k columns, proportional to k squared, this expression here, of course. And as noted, odd and even blocks are above or below the diagonal. So that means that if we do 2 blocks in sequence, if we need to delete 2 in sequence, then they are not adjacent. So there are some useful additional properties with respect to that, which we're not getting into today. We can also extend this to multiple dimensions as much as we want. This is just an illustration of how it would look extended to 3 dimensions. Instead of the above and below sectors, we have 6 sectors corresponding to these 6 faces here. Just as sort of an interesting possibility. We have not implemented that for Hyperledger, but that could be considered in the future. And of course, that would, the idea there is it would shorten the length of the hashes if needed. So
Rick,
yes,
just, you have plenty of time, so you don't have to hurry.
okay. All right. Well, thank you. So comparison. Just a quick review. Again, distributed trust, we want that for both. And integrity protection, that's provided through hashing, as we would have for the blockchain. But this is the key difference. In blockchain, we have immutable records, and in the data block matrix, we have redactable or editable records. And that's a point, so they don't necessarily have to be deleted. They could be changed for correction, exception management, and that sort of thing. So why would we want to use this? Again, we don't need blockchain or all the features of blockchain for some applications. We only need some of them. So what this can do, we think, is enlarge the market for blockchain. So we can have more applications that can use the features of blockchain, but without some of the complications, because we are dealing with this issue of privacy regulations. And of course, exception management. This is always important in in many business applications. And so this capability will allow for this exception management. Another interesting feature, we could replace network communication with local data, and part of the application that actually my colleague Joanna DeFranco will be talking about on Thursday is looking at a database that uses this data block matrix function. And one of the things that's done there is to replace network communication for permissions and attributes of users with local data. So you could do this on any database, of course, but what we have done with this feature is add the integrity checks, add the integrity protection that is provided typically in blockchain. So we can do basically better security, better database management using this as well. And this is intended as a basic, simple, easy to use component that we could use in designing distributed databases. So there's a lot of discussion sometimes about why blockchain is so valuable, but why it has not really taken off in a lot of applications. And I think we don't want to get into the details of this complex chart here, but I'll just call your attention to the column down the left side here. If we look at these different questions here, if you meet all of these criteria, then according to this blockchain, which was developed by NIST and DHS, if you meet all of these criteria, then you might have a useful application of a blockchain. So there's an awful lot going on here. There's a lot of different things that need to be considered. So what this data block matrix does is address these 2 points right here, the points in yellow: data records needing to be updated or deleted, or sensitive data being recorded in the database. So those considerations may be obstacles in using conventional blockchain. So what I'm presenting today is a way to avoid those 2 obstacles. So that can help quite a bit in making blockchain more useful for practical applications. With respect to technology transfer, we have a little internal project support that we used in generating the Hyperledger component. And there is a patent for this. This is basically to assure the availability of the technology. I won't make any money off of it. I don't think the US government will make any or very much money off of it, but it is owned by the US government, of course. But this is the most important aspect here, is that this is a Hyperledger component, and this can be used in different applications. And with respect to Hyperledger, many people are familiar with it, but if you're not, this is a very widely used blockchain open source project started by these major companies, IBM, Intel, SAP. Large distributed systems are the target application. And it's designed, the feature that we have is designed to use the Hyperledger API as closely as possible. Ideally, you could take a Hyperledger application and incorporate this component without any changes. Now, if you want to add the capability of deleting the data, then we have an API for that as well. So this is being called what we have here, redactable enhanced distributed ledger. So red ledger. We think it's nice. And Joanna DeFranco was actually the one that coined this, the one you'll hear from on Thursday. So there is a website for this, and also for the data structure itself, which I'll have these at the end of the slides also. Now, integrating with Hyperledger Fabric, again, we tried to make minimal code changes. The changes are being restricted to this particular package, block storage, so that will minimize the need or the effort in future updates. And this also can be configured by channels. So a channel within Hyperledger is basically a private subnet. So you can configure a channel to use the blockchain, conventional blockchain built into Hyperledger, or to use the block matrix. And if you have two channels, you can have one using blockchain and one using the block matrix. So it gives you a lot of flexibility in your distributed database application. Just to illustrate this, again, no change for the code is required for the application layer. Within Hyperledger Fabric, we've had modification of just this single module here, the block storage package. It's in Hyperledger Fabric, widely used, an existing API. And of course, the current applications of Hyperledger Fabric are what we've targeted this for: supply chain, logistics, e-commerce, that sort of thing. In theory, it may be used for digital currency as well. We have not tried to do that, but that's something that could be done. And there is some interesting work I've seen from the European Central Bank and others looking at how you would use Hyperledger within central bank digital currency, perhaps. So that might be something for the future, not for now. So where do we go next? Well, we are supporting the open source release of this. We want to demonstrate it with clinical trials. Some of this will be presented Thursday, and that report that I mentioned on the European Central Bank and central bank digital currency. That could be an interesting application. It's a pretty small project, but I wanted to thank everyone here. Josh Roberts has implemented the code, and Sylvain Chantreau have implemented the code, and the rest of us have been involved in various parts of this. This is the website, or the right here, that describes the technology, describes the data structure and the properties, shows those properties. And this is the site Redactable Distributed Ledger, where the code will be stored for download in the next few weeks. We also have a nice little article, sort of a high-level, easy read article in IEEE Computer a couple of years back that explains this, the reasons for doing this, and what the properties and advantages are. This would be an easy to find article. If you need that or any other article, I can easily mail those to you. Just let me know if you're unable to reach those. And thanks. Open for any questions now.
Thanks, Rick. Any questions on the channel? Let me take a look.
Yes, if you could read those.
Okay.
Oh, sorry, I didn't mean to stop the screen share.
That's fine. I think there's somebody. Oh, Gora has his hands up. Gora?
Yeah, sure. Yeah. Thanks, Rick, for a fascinating and excellent introduction to block matrix. Besides Hyperledger Fabric, is there any intention to move to other platforms as well?
Well, that could be done. It's basically a resource question. We have a very small team, of course, so most of the code has been implemented by one staff member. So it could be done. We don't have immediate plans for that, but if there was a need for it, or if there was a company or an agency that wanted to have that, then we would definitely work with them and try to make this available on other platforms as well. But we could certainly do that. It's just not planned at this time.
All right, great. But then others can take, because it is open source, it is readily available, so they can take the essence of that and then bring it forward.
That's right. Yeah, the code will be there on the site, and then others could use this.
And Rick, I have another request for you, because we actually started with you early on.
Okay.
If you don't mind just going back to your first slide or one or two slides and repeat that, because a lot of folks joined later on, and the question like, what is block matrix is coming up. So you may want to just quickly give us an overview.
Okay, just 1 second. Let me see if I can break out of the full screen mode here. Okay. Yes. So if you wanted this is the first slide. If you want that, I could show the data structure itself. Would that be helpful?
Yeah, just tell people, because there's some folks who joined a little later, and so they're wondering
Yeah.
what exactly is block matrix.
Okay, this is what it's all about right here. So the data block matrix is basically trying to provide two of the three key points of blockchain, provide distributed ledger and integrity protection based on hashing, but allow for controlled edits for privacy. So you can think of it almost as blockchain without the immutability property. And I should point out that there have been other people have looked at this immutability property of blockchain and ways to try to get around that. So this is maybe a little bit different in that we're not trying to use conventional blockchain and get around the immutability obstacle, so to speak. What we're trying to do is something that is different from blockchain, but provides the two key properties, distributed trust and the integrity protection. So it's a different way. It's distributed ledger technology, but it's not strictly blockchain. And so this is what we're really trying to provide: edits for privacy as required by many regulations. A lot of the regulations that are in the business world can make using conventional blockchain very difficult. And as I argued later, I think that this is one of the reasons why blockchain has really not taken off in the same fashion outside of cryptocurrency that many people thought it might initially. So we're hoping that this can help to do that. Basically, we want to expand the range of applications for a distributed ledger. So try to move this boundary right here to make it more useful for certain applications, not to replace blockchain, but to allow the use of blockchain type properties with other features.
Thanks, Rick. I think there was a question from Razwan, correct? I saw his hands up.
Okay.
Let's see if we can elevate Razwan to Razwan.
Yes, hello, Ramesh. Congrats, Rick, for the presentation. I'm an auditor by profession, and I particularly like your presentation. We have also done a prototype and presented yesterday as to how the economic transactions can be put on a blockchain, not only the payments between two economic actors, but actually the real transaction, recording the rights and obligation of a particular transaction. And I'm inspired by your presentation, and we are further looking to find a solution to the problem whereby the details of an economic transaction can be put on a blockchain to ensure the immutability and all the features provided by the blockchain. But maybe the participants do not want to show sensitive commercial information. The question is, could your tool be used to, let's say, hide the certain transactions that are on the blockchain but would be available only to the supplier, the customer, the auditor, or the tax authorities?
Yes, as a matter of fact, we have implemented this in an integrated fashion with what we've called next generation access control and next generation database access control. So it's been fully integrated into a database system with full access control that allows you control down to the field level. So if you have records within a database, you can control access to individual fields, not just the records themselves. So that's been a key goal all along. And we're making that, that code is available also. If you want, send me an email and I can get you more information on that. Also, the talk on Thursday by Professor DeFranco will discuss this access control aspect in much more detail.
Thank you for that. I'll do so. Thank you, Rick.
Good.
Rick, there's a long question or comment in the chat box. Are you able to read?
Yes. Okay. Let's see. Okay, the URLs, they are on there.
Keep going down to
Yes.
Michael, as says Merkle roots. It starts like Merkle roots have nice summarization.
Yes, a summary hash, like a.
Oh yeah, maybe we can let him speak. Michael, you want to speak?
Yeah,
Go ahead.
my apologies. So Rick, I just made a comment that binary hash trees are pretty efficient, have n log base 2n properties of accessing and changing the hashes back to the summary root, which is usually the Merkle root. And that Merkle root is normally inserted into the block header. And it's the block header that gets hashed in the time mechanism. So my question here is twofold. One is, it looks like you use a lot more hashes, and that isn't so much a problem, I don't think. But that now you lose the Merkle root method of putting something in the block header that ties all your data that you could have changed in the transaction field in the blocks. And I'm just wondering, what mechanism do you have there in place of that? I'm sure if I read these documents, I'd be able to figure it out, but since you're there, I figured I'd ask you. Thank you very much.
Yeah, so I read your question. I agree. This is basically, I think you've made a good observation. That is basically, we're using a hash which is recorded and does not have that root, but this is to allow the flexibility. There's different ways that we could do this, and that might be an interesting sort of research question, is look at some of the other possibly more appropriate ways to do that hashing. But at this point, it's simply a very simple hash of the blocks that are there in the row or the column. So that's something that we could look at in the future.
No, but be sure to ping me on that. I've got some ideas, but I have to read your documents first. Thank you very much.
Yes, of course. Thank you.
Looks like Anton has a follow-up comment on this. Anton, we could make you speak. Let me see if I can find you.
Yes, yes. Again, this is. I agree. This is a good observation that with this square matrix, it's basically quite a right number of hashes. We can do it. We can do it efficiently, and so far it has not been a problem. Now, if it's expanded to a huge application, I think that it would still work fine, but we have not attempted to do performance numbers on gigantic database applications. But for the applications that we're considering, it seems appropriate, especially when we're looking at permissioned databases. Again, I mentioned auditing is a very valuable thing. So if you've got a logistics operation that involves 10, 15, 20 different companies, different, globally distributed, it's not a huge problem, but there's a lot of need for the distributed trust. So this gives us the ability to handle that type of application.
So you are having a quadratic number of hashes.
Yes, yes. Oh,
yeah. Okay.
So let's see, application of block matrix in healthcare, in particular patient data. Yes, that is the first application that we started looking at for clinical trial data. The idea there, and this also gets into the integration with next generation access control that will be presented on Thursday, because that's the sort of thing where there needs to be a guarantee that the data is correct, but we need to be able to delete certain parts of it that are private data. So by using this next generation access control combined with the block matrix, we can deal with privacy aspects of certain fields, certain bit data, but not others, so that it's a nice fit with clinical trial data or patient data in general.
Rick, you mentioned, I think DHS in the beginning.
Yes. Oh, that was that flow chart of where a blockchain would be useful. That came from DHS, and NIST put that together.
Okay. And I mean, you mentioned a few applications. Like, what are the things you're looking at right now? Like, if you were to summarize, I heard, food supply chain, you're going to talk about it tomorrow, I guess. And you just talked about healthcare or health data. What other applications are you looking at, and who's interested in terms of putting this into use, practical use?
Yes. Well, there is interest from clinical trials. People that do this. This is an important societal function, but also a big business is doing clinical trials, and so we have interest from there. And logistics is something that we think it would apply to very well. We have not tried to do a use case in logistics, but supply chain aspects. So there's the Smart Cities 2030 project in the EU, and they have been looking at this. So that's sort of a broad application. That's how Latif Ladid brought me into this, I believe, is through that. That's a supply chain issue, a broad supply chain issue, and this could be applied also, we hope, to supply chain issues with respect to semiconductors. NIST has a major project in semiconductors getting underway, and this may have some value in that area as well.
Okay. Let me see. Any other questions? So I have another question. You mentioned about how this block data matrix could be used in scenarios such as like GDPR compliance and
Yes.
things like that. Have you looked at EPSI project, European Blockchain Service Infrastructure, that European Commission has funded it? I heard they put in like 700 million euros. It's a big budget, but I found out later Hyperledger is behind it somewhere. So have you looked at it?
Well, now I'm not sure about the particular project, but I should have mentioned earlier that the European Telecommunication Standards Institute has an interest in this work, and ETSI, and they have included it in some documents, and those documents are linked on our website. So if you take a look at the website that I presented at the end, that has links to the ETSI documents that discuss some of the use of this.
Okay. There's more questions here. I see. Besides clinical tires, that's Gora. Iqbal, let me see if we can elevate him as a speaker. So you should be let him ask. It's a lot better when people ask.
Okay.
Like reading. Can you speak?
Anybody can unmute themselves.
Oh, okay. Okay. I didn't know that. Okay.
Yeah, it's Iqbal here, Rick. Just a quick question from my end. I just wanted to know if this conference was going to have something specifically on logistics and supply chain. There's a lot of use cases that are going around. I'm actually in conversations about one of those. Would love to participate.
Yes. Well, I don't have the agenda right in front of me. I think Gora,
I'll step in. Yeah, sure. We have a full track on food supply chain. So if you look at the agenda, you will find that.
That's tomorrow, but then you've got others as well, right?
We have other tracks, but the one which is just pure logistics supply chain was something which wasn't there. It was there earlier on, but it's no longer there.
Yeah, and I'll be presenting most of this same material in the food and supply chain session tomorrow as well, because it's tied with the other one which I talked about earlier on the clinical trials application. So it's sort of companion talks back to back. So I'll be giving that one, and then Professor DeFranco does the next one.
Great.
And we also have another clinical trial session as well. So
right, on Thursday at 4 p.m. Right.
So check the agenda on your app.
Yeah, a lot of fun.
Thank you, Gora. Thank you, Rick.
Rick, this is now a general question. I do see Katya Dilak on the call as well. I wanted to understand, let me share what I find if I just look on the NIST website, right? You do have a landing page for blockchain, and I see a list of projects here. So could you tell, either you or Katya, could you tell folks what you guys are doing? There's quite a few people that are involved in blockchain. And if I do a simple search, I see 10 publications, which is pretty good. You guys are productive. So tell us what you guys are looking at. More than, I mean, of course, we heard quite a bit about your block data matrix, but tell us what else are you guys looking at?
Oh, yes. Okay, well, there's a number of things. And there is some work looking at cryptocurrency. There's a fairly recent publication within the past 2 months on stable coins, looking at the properties of stable coins for cryptocurrency. There is a previous publication. I was not involved in that one, but my colleagues are. There's a previous publication looking at cryptocurrency as well. These others, industrial applications, I think this is a more general community of interest. This one, Enhanced Distributed Ledger, that's our website, in fact.
Oh, okay. Let me get that. I think you posted it, correct? To the folks on that.
It's at the end of the slides. There are 2 websites linked there. One is the one on the data block matrix, and the other is dedicated to the open source release.
Will you go ahead and post those, please?
Yeah, please
Rick?
post it there.
On the chat.
Yeah, there were quite a few folks who were interested, so they may want to just.
Yes.
Okay, yeah, I see that, and I can also post this link, but this, I don't know if this is up to date, but I see comments February. Okay. I don't know if Katya.
Copying,
okay, cool.
the links into the chat here.
Let's see. Oh, Katya is here. Are you able to speak now? I see your audio.
Yeah, his audio is on.
She kind of leads. She's still leading the blockchain efforts, Rick.
Oh,
I thought Katya on the call.
yes. Oh, yes. Right.
Maybe she said some issues with her audio. Maybe, you know.
Oh, I see. Yeah, I didn't hear anything.
That's okay. That's it's probably trying to. Okay, so in terms of, so I mean the link you shared is about the work you're doing. Okay, she has trouble with audio stuff. That's fine.
Oh, I see. Yeah.
But cool. Well, I think I'll share this link as well, folks who want to know more about what NIST is doing on blockchain. I will share this, and it's just okay. I'll put that here.
Good.
Sorry, that's for. Let me put it for everybody. Is that up to date, Rick? This page?
The page that you're showing in the screen, I don't know if that's up to date because this is not mine.
Yeah.
Katya could probably tell you that.
Yeah, that's fine. And then in terms of publications, I did a search, so you guys I can share that as well. You can see all the publications coming out of NIST there. So our audience have all the links about NIST. You may get lots of emails. Okay, cool. Any other questions, comments for Rick? Or even Katya, you want to share something on the chat? I know you have problems with the audio. That's fine. If not, let's not bother her.
Let's see. Yeah.
Cool. Thanks a lot, Rick. I think
one last question.
Sure. Go ahead. Who is that?
I guess, just from my understanding, is the IEEE, blockchain conference that we're part of right now, is it is the expectation that this becomes a de facto, standard setting place for blockchain related going forward, emerging technologies, whether in hardware and software, or like, what is the purpose of, and this might be a novice question, so I, apologize in advance, but is this more of a standard setting type of, conference, or is it more of, discussing what is, up and coming about blockchain and, finding, partners or collaborators?
It's the latter. It's about learning the latest advancements, like what Rick presented, some of the interesting research work, and and of course you could find collaborators to work with, and we're doing this hybrid. Maybe next year will be in person. It's where you can make some connections and find people to work with across the globe. You talked about standards. So standards is let me share quickly, since you brought up standards. I can share perhaps Rick, you can comment after I tell about what we are doing, because NIST, standards is in the name. So it's let me share. So if you go to our website, blockchain.ieee.org, right? That's our main website. And you click on the standards tab, you'll see a whole list of standards working groups. We have 11 published standards here, and there's lots of working groups. And you could just contact the working group chair and participate in the working group. If you don't hear from them, you can always ping me or one of us, like Gora, myself, who will try to get you connected. So that's the standards within IEEE. It's ongoing. Now, Rick, you want to comment about standards and, is there anything?
Yes,
you did mention about it. You did mention about Etsy, so I'll let you speak about
well,
it.
I just wanted to clarify the role of NIST in this sort of activity. We are there to support the industry which are developing consensus standards. So our interest is in providing measurement and test capabilities primarily that support industry standards. So industry takes the lead on this to develop standards. And Etsy is one example. IEEE, of course, huge in standards. And so that's our role. So we are not a regulatory body. We don't dictate standards that should be used by everyone. We support the consensus standards that are developed by industry, either nationally or internationally, depending on the application.
Understood. Thank you very much, both Ramesh and Rick.
Yeah, by the way, I want to add what Katya shared. So Katya is at NIST as well. She just posted on the chat that NIST is.
Oh, yes. Dylan Yeager is involved in this work from NIST, many others involved from other organizations.
NIST is a participating organization through the United States, I guess, as delegate, U.S. delegate. Actually, is that the term? Yeah,
that's very good.
One of the U.S. delegates through ANSI, I believe. But anyway, it's a long story, but short story is NIST is participating at this ISO TC 307 blockchain and DLT committee on standards. So I think anything else? Any other comments, questions?
Ramesh, I'll go ahead and clarify and add to what you explained about the future. So this is the very first incarnation of GET, the Global Emerging Tech Blockchain and Beyond. The idea is that this will become an annual event, number one. Number two is we will not be focusing just on blockchain, as the name signifies. And thank you, Rick, for that excellent plug. It is blockchain and beyond. So blockchain does not live in its own silo, but it interacts and has application in other emerging tech. And that's the interplay we want to highlight moving ahead and become the de facto industry conference in this area.
Great.
Cool. Thank you, Rick. And thanks, Katya, for posting about the ISO TC 307 participation. Any other questions, comments before we?
Yeah, we have our next keynote speaker also lined up, which is fantastic. So, Rick, thank you. We pulled you in early, but thank you for hanging in there. So.
Yeah, we had some interesting. It became like
glad to do it. This was incredible discussion. I mean, I'm really impressed. This has been very good.
Cool. That's good. That's
thank you.
Part. Yeah.
I will be hanging on. I'm going to shut off my audio and video now.
Sure. Yeah. Welcome to hang around. So I would like to take a couple minutes, Gora, to talk about what we've been doing.
Sure.
The initiative. Let me share my screen. 1 second. Okay. Okay, now we have more folks on the call. So the IEEE Blockchain Initiative is, think of it as a think tank. You know, we basically bring people like, you know, Rick and all the speakers together to collaborate, share the latest developments, and, you know, brainstorm. And you know, so it's a forum, and it's run by volunteers. So we always welcome folks to join our team and do whatever they like to do in terms of, you know, within the scope of, you know, our interest. But, you know, Gora has been saying it's blockchain and beyond, so I guess the scope is now larger. So we do. One thing I want to point out to folks who are new to, you know, this, you know, conference or this community, please go sign up. Well, first just go to blockchain.ieee.org. That's our landing page. Yeah, here's a QR code you can scan and get there. You know, you could click on the tabs, each one of the tabs that basically you will find details about the activities under each one of these tabs. And I encourage you to join all of the social media platforms here, you know, Facebook, LinkedIn, Twitter, and also, you know, there's a link here where you can join Collaborate space. That's more like a, you know, posting, you know, like a board, electronic board. Now, this is a kind of a global network, right? Now, if you want to be locally active, you know, take a look at this list here and see if there's any group in your area. You could get involved at the local level as well. So you see there's two ways to get engaged globally through these, you know, social media platforms, as well as locally. You can be part of these groups. And
I'm just
Sorry?
looking at the time. So
yeah, so I'll stop here. And that's pretty much what I wanted to share, because quite a few people are new here.
All right. So with that, thank you, Ramesh. Thanks. Excellent segue for what's coming next is the next keynote. While
Gora, we want to stop and then restart the recording. So what time do you want me to stop?